last time we saw. Question 4A, correct? Is it correct? Question 4A. Okay, so now we continue with question 4B. Okay, for the question 4B, okay, it's asked. Alright. A microprocessor class consisting of 16 students that just completed a test, right? And then their marks are stored consecutively in a memory location beginning from address hundreds, right? So you have here 60 students in which the marks of this student here are stored starting from address hundreds. Okay, so you have 60 byte lah. Okay, total of 60 byte here. Okay, to store the marks of these students here. Okay, you are required to find the average. Okay, you need to find what is the average by using AVR assembly language. Okay, so you need to find what is the average. Okay, find the average. Okay, you may start finding the total marks of all students and divide the result by 60. Okay, so average, what happens if for average, you need to total out the mark for 60 students. Okay, summation for 60 students and divide by 60. Okay, so you get the average. The problem is there is no division instruction in AVR microcontroller. Okay, so in the microcontroller there are no such division instruction. Okay, so fortunately someone has provided you with a division subroutine. Okay, so the division subroutine is already been provided to solve this problem. Okay, so this subroutine detail are as follow. Okay, the subroutine name is divide. Okay, the input parameter are R21 for higher byte. Okay, so you have a R21 and R20 for lower byte, while R19 is your divisor byte. Alright, so this is your divisor byte. Okay, while this is the input. Okay, input that coming to your divide subroutine. While for the output, okay, the output from this subroutine here, R23, okay, will show the whole number, okay, which is the number bulat of the result, while R22 is the fractional number. Okay, mana pula? Okay, while R22 consists of fractional number, okay, which is number perpuluhan. Okay, so R23 is your whole number, while R22 is the fractional number. Okay, so what you're going to do is you are going to write an AVR assembly language program to do the task by making use of the provide subroutine. So you need to use this subroutine here, okay, to find out what is your average of this student marks. Right, continue from this following codes. Okay, it already given you include empty2the-def.inc starting at org at 0 and then load I R16 high remain out SPH R16. Okay, first thing first. Kenapa I give no the link I gave you earlier is the same link if not mistaken. Okay, let me check. Yes, the same link. Okay, so let's continue here. Okay, first thing first, what you're going to do is, here is, because you are going to use this divide subroutine. Okay, every time you're going to use the divide subroutine means that you need to initialize your stack pointer. Okay, so ingat, setiap kali you're going to use the subroutine, this is for what we call here, for assembly language lah. Every time you're going to use a subroutine, make sure that you initialize step pointer. Okay, because you're going to use the call function and return function. Okay, so for subroutine, there are two instructions that you're going to use, which is call and return function. So that's why we're going to initialize the step pointer. Okay, similar to your quiz yesterday. Okay, you are going to use the subroutine. Okay, for the delay. So what you need to do is you need to initialize your step pointer. So if you initialize your step pointer, then you get marks lah. Right? If you not initialize step pointer, so you're losing a mark there. Okay. So now, okay, for this is how to initialize your step pointer. Okay, load I R16 high ramen out SPH R16, and then the other instruction that you're going to do is load I R16 low ramen and out SPL R16. Okay, so this is to initialize your step pointer. Okay, that is the first thing. Okay, you need to initialize your step pointer. And then next, what you're going to do? After you initialize your step pointer, what you're going to do? Anyone? Okay, you're going to do a loops, betul tak? Okay, because you're going to read, okay, the marks that been stored from address 100. How many loop that you're going to do? Are you going to, what is your counter register? So your counter register, in order to do the loop, you need a counter register which consists of 60 lah, sebab you need to read out 60 marks that are being stored starting from address 60. Okay, so you initialize your counter. So load I R17 60. So this is your counter. Okay, next. Lepas tu nak buat apa pula? Okay, you see here R21, R20. What is it actually? Okay, this is the result. Okay, to do the average, okay, you need to add all these marks here, all of the 60 marks from that student. And then, since this one here, okay, let's say lah, all the student is excellent lah. All our student got berapa ni? 100 marks. So 100 multiplied by 60, you get berapa? 6,000. Okay, so for 6,000, okay, to store a 6,000, you need at least 2 byte of register. Okay, you cannot use 1 byte. Okay, because it's greater than 255. For 1 byte, you only can hold 255. Okay, the maximum value is 255. Okay, since this one here is 6,000, so you need 2 byte, because 2 bytes, okay, if you convert, it can cater up 65k. Okay, so that's why you need to you're going to store, okay, your hasil tambah here of your student here, student marks here, okay, by using 2 registers. So that's why the hasil tambah here will store at R21 and R20. So this is the hasil tambah. Okay, so the total marks. Okay, you store all the total mark inside R21 and R20. So first thing first, what you're going to do is you clear lah R21 and R20. So clear R20. So clear R21. Okay, next. After you clear the R21 and R20, what are you going to do? Okay, how to read the what we call the student marks? Macam mana kita nak baca student marks? Okay, R21 and R23 is input to your subroutine divide. It's an input to your subroutine divide. Okay, so you need to 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 read the question clearly. Okay, R21 and R20 is the input parameter that are going to your subroutine divide, not the input which is connected to your switch. No. Okay, next. Macam mana? Okay, so how we are going to read the data that been stored at address 100 ni? Macam mana kita nak buat? Okay, you need to use a pointer register lah. Okay, so make sure that your pointer register point to address hundreds. Okay, so what type of pointer register that you're going to use? We have 3 pointer registers, so let's lah kita use pointer register Z. Okay, so first, what you're going to do is you need to make sure that your pointer register Z point to address 100. Okay, how to do that? Load I. Okay, so this is Z, and then this is the address. Okay, 100. You have an address 100. Since your address 100 actually is a 16-bit data, so you can divide to 2 byte, one low byte and the other one is high byte. So your pointer register Z also consists of 2 byte. One is ZL, the other one is ZH. So 00 will go to your ZL, while 01 will go to your ZH. This is how you want to initialize your pointer register. So load I R, okay, I just R31. Okay, so R31, where is your R31 with 0x01, and load I R30 with 0. Okay, because this is your R30 and this is your R31. Okay, lepas tu nak buat apa pula? Next, what are you going to do? Okay, satu lagi. The thing that you miss here is R19, the divisor byte. Okay, so you need to load the R19 value. What is the value for R19? LDI R19. Yes, 60, because you have 16 students. So the divisor byte here is 16. Right. Lepas tu, next, what are you going to do? Okay, this after you initialize all the GPR. Next, what are you going to do? Okay, you load lah. Okay, you read the first data. Okay, the first mark that stored at address 100. Okay, read out the first data that stored at address 100. So how to do that? By using the LD instruction. LD, okay, let's lah kita ambil kat sini R18. R18 Z plus. Okay, means that first go to address pointer by Z, which is address 100. Take the value, put inside your R18. Okay, next, what are you going to do? Lepas tu, after you load this number here, what are you going to do? Okay, you need to store in R21, R22. Okay. Okay, before we proceed with the next instruction, okay, so this is your R31, R22. Okay, so this is the result lah. R31, R22. R20, sorry. Okay, so you need to plus here. Okay, let's the first register here. This is R21 and R20. You plus with, let's say lah, this one here we use the R berapa lagi kita tak guna. Okay, R18. Okay, let's say lah, this one I use the R22 with R23 with R22. Okay, so this is your result. the result you need to put inside R21 and R20. So R22 is actually, okay, the value that you load from your memory, okay, from the memory address here. Okay, so this is the value, the marks that you load from this memory address here. What about R23? R23 you need to put always 0 lah. Why 0? Because we want to add 16-bit number. Okay, because we want to add a 16-bit number. Just now we already find out that, okay, we have a total of 60 students. Let's say all the students have 100 marks, so the total marks will be 6,000. Okay, for the 6,000 you need to store in 2 register, okay, 2 byte register. Okay, so that's why in this case here we are going to store at R21 and R20. So why not R21 and R20 we put up here, and then next we need to have another 2 byte of register, which is R22. The R22 is the value that you load from your memory here. Okay, the memory address here starting at 100, while R23 always 0. Okay, so that's why here kat sini, okay, so we change lah, not R18, kita pakai R22 Okay, to make it more clear, so this one here, okay, load the value from point by Z to R22. And at the meantime here, sebelum tu, okay, before we do this one here, we need to clear R23. So that R23 always 0. So clear R23. Okay, next, barulah kita add this number here. Okay, by right, okay, the first value here, okay, by right, when Z is pointed at 100, okay, so what happened is R21 is 0, 0. R20 is also 0, 0 because we already clear kat sini. Okay, plus with, okay, let's say this one is 100. 100 in, okay, the first student is 100 mark. 100 in hexa. Can you change this one to hexa? Where is the number? 100 change to hexadecimal. Boleh tolong tak? Do you have a calculator? Okay, 64. Okay, so this one is 64. Okay, so R23 0. So what happened is you get 64 and this one is 0, 0. And your Z is increment. Now Z point to what address? 101. Okay, which is the second student lah. Okay, let's the second student. Okay, yang tu nanti kita buat in the next cycle. Alright, so what you're going to do is you need to add this number dulu. Okay, so since this one here, see this addition is 16-bit, so what happen is you're going to do you can divide it to low byte and high byte. For the low byte you need to use the ADD, while high byte you need to use the ADC, because sometimes you got a carry from this low byte, so you need to consider that carry. So sekarang ni we use the ADD R20 with R22. Okay, followed by ADC R21 with R23. Okay, semua boleh follow ya? All of you can follow ya up until here. Any question up until here? Ada soalan tak kat sini? Okay, next. After you add these two numbers here, okay, all this number here, so all the number will be stored to R20 and R21. What happen is you need to decrement your counter register. This is your counter register. So decrement R17. Okay, after you decrement R17, because we want to load the second number, okay, which is the marks of the second student. Alright, so decrement R17. After that, after you use the decrement R17, you use the BRNE. If R17 not equal to 0, what happen is you go ulang. Okay, where I want to put this ulang here, so I put kat sini. Okay, now sekarang ni this is the hasil lah for the first student. Okay, this is the hasil tambah for the first student. Okay, let's see the hasil tambah for the second student. Alright, so now we go to ulang, load R22 with Z. Okay, what is our Z? 101. Okay, let's say lah this one also 100. This guy also got 100 marks. Okay, so 64 plus with 64. Okay, so this one kat sini 00. Okay, you get C8. Okay, 00 C8. Decrement again R17, branch not equal, ulang. So you do ulang. So the third student also 100 marks. So now you got total of 300. Betul tak? 100 plus 100 plus 100, 300. 300, if you convert this 300, kamu akan dapat apa? Okay, 1 to C. Okay, let's see here. Betul tak? Dapat 1 to C. Okay, so this one here, okay, load R22Z. Okay, you load again with the Z value which is another 100. Tambah lagi 64. Okay, 64 tambah C8. 64 plus C8. What you get? You get 1 to C. Okay, 01. And this is 2C. Okay, 64 plus 68, you get 2C. And then you have a carry 1. 1 plus 0 plus 0, you get 1. And you get the same answer with this one. Okay, so this is your okay the how to get the total marks lah. Okay, it will do 60 times. Okay, after you finish the 60 times, what you going to do lepas tu? Okay, you need to okay, we see back kita punya equation here. What is our equation for average? Average sama dengan okay, total mark of 60 student divide by 16. Now you're going to call your divide subroutine. Okay, because the divide subroutine already been given. Okay, so you use the call divide. Okay, so this is the input lah that going to your what we call here the divide subroutine, in which R21 and R22 is the total marks of the 16 student, while R19 is the divided by. Okay, it will go to all these value here will go to your divide subroutine, and after that this value will produce R23 and R22. Okay, the result from the division will be stored to your R23 and R22. So what you're going to do here is okay, kat sini dia ada bagi tahu tak store dekat mana-mana. Okay, let's say lah saya tambah lagi another 2 sentence here. Okay, let's okay, saya tambah kat sini ya. Let's R23 store dekat address 200, while R22 store will be stored, the result of R22 will be stored at address 201. Okay, how to do that? Macam mana nak buat? Okay, we're going to use the STS. So STS 0x200 from which register? Okay, sorry. Okay, 200 we store R23. So you just put STS address 200 with R23 and STS address 201 coming from R23. 20, 22. Alamak, guys. Sorry, guys. Okay, so this one is just... is it make a sense here? Okay, can we change this register here kat sini? Register kat sini. Because we mix up with the output from division subroutine. This register here, can we change this one here? We cannot use the R22 and R22. Let's say this one we use the R24. And this one is R25. Okay, because I don't want to mix up with this register here. Okay, so yang kat sini, okay, so this one here clear R25. Okay, so let's change this one. We use the R24 and R25 instead. Dekat sini ya. Boleh ya? Okay, any question tak? Any other questions? Ada soalan tak untuk Q4B? Yes, so R22 yang kat sini we tukar dengan R24, while R23 here we tukar dengan R25. Okay, kat Z, yeah, satu lagi. Okay, kat sini, yeah, correct. This one here we also tukar with R24. Okay, thank you, Amir. Okay, if no question, next we go to the section C. Okay, so this is a C programming, yeah. Because this one here I take from 5 or 6 year back. Okay, since in that time, okay, in that time we don't have any C programming. All of the programming are in the assembly language. So we just replace all the what you call it, assembly language with the C programming. But the question is still the same. Okay, just convert the assembly language to the C programming. Okay, let's say at question 5 here, you are required to design a basic AVR circuit to have the following components: ATmega32, 2 7-segment display, 8 push button switches, 8 LEDs, reset circuit, 10 MHz clock oscillator. Okay, and the following codes are going to be used to display digit 0 to 9 to your 7-segment display. The code for digit 9 to 0 display are as follow. Okay, so you know that this is to display kosong. This one is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, question A. Complete the following ATmega32 circuit in figure Q5 to have a supply. Okay, you need to connect to power supply, a reset system, clock oscillator, and 7-segment display. They are connected to port C. Okay, so make sure that your 7-segment display are connected to port C. Okay, let's connect our 7-segment display, and after that we do the clock oscillator, reset system, and power supply. Okay, so this is your port C. Okay, all of these port C here will be connected to your 7-segment display. Okay, so you need to label all the connection here. Okay, since this is PC7 going... Okay, so we started with PC0. PC0 are connected to A, followed by C, B, C, D, E, F, G, and H. Okay, semua dapat ya? Okay, because in the 7-segment, A is your LSB, while your H Okay, this is your LSB, while H is your MSB. Okay, so make sure that the connection is correct lah. A should connected to PC0, while H connected to your PC7. Okay, but the question here is, what type of 7-segment display that you're going to use? Is it a common ANET or common cathode? So in this case here, what type of common 7-segment display that you're going to use? Common ANET ke common cathode? Is it a CA or CB? CA or CC? How to figure out the common configuration of your 7-segment? Macam mana nak cari? Okay, how to identify the 7-segment here that you're going to use? Common cathode. Why you say common cathode? Why you saying common cathode? Kenapa common cathode? Why common cathode, not common ANET? Kenapa? Okay, you need to refer back to your ni lah. The codes here. Okay, you see this code here. 3F. 3F will display 0. Okay, betul tak 3F is 0? So you you draw your 7-segment A, B, C, D, E, F, G, followed by your H. Okay, 3F. What is 3F? 0, 0, 1, 1, 1, 1, 1, 1. So this is your A and this is your H. So A, B, C, D all lights up. A, B, C, D lights up. E, F also lights up. While G and H, okay, turn off. Okay, so it will display 0. Okay, so this one here. So you know that. Okay, now we know that we put one LED on, turn on, while we put 0 LED turn off. So this one here is a common cathode. Okay, you put one LED lights up, while you put 0, the LED turns off. Okay. Okay, next. Okay, we're going to connect the power supply. What about the power supply here? Okay, so VCC connect to VCC lah, 5 volt. Ground should connect to ground. Okay, so this ground here also need to connect to ground. Okay, so this is for the power supply. Okay, next. Okay, we finish this one and we finish this one. What about the reset system? Macam mana reset system? How to the connection for the reset system? Okay, so for the reset system, which is a pin number 9. You see here, this is pin number 9, ada reset button. Okay, so this one here connect to your reset switch. Okay, so the reset switch is active low switch. Okay, every time you press your switch, it will give 0. Okay, so you just put something like that lah. Okay, so this is your reset system. And last but not least is your clock oscillator. Okay, what about clock oscillator? Macam mana nak buat clock oscillator? Which pin out here that we need to connect it to our oscillator clock? Pin berapa? Connect to oscillator. Okay, luckily for you, you can, for this semester, it is an open book test and final exam, so you can refer to your books lah. If not, what you going to do? Kat mana? Okay, pin 12 and 13. You need to know all this pin here. What this pin do? Okay, you see here, pin 12 and 13, 12 and 13 is used to connect to external 2 and external 1. So this is where you need to connect your clock oscillator. Okay, so you take a, okay, sambung pada kamu punya oscillator. Okay, just like that. Okay, so we finish question 5A. Okay, what is the SKEE program to configure in port port in part A. Okay, how to configure the port in the part A here. Okay, since this one here, which port that you using? Port mana yang kamu guna dalam figure Q5? Only port C. Okay, this port C here you connect to your 7 segment display. So how to do that? How to configure your port in part A? So you make your port C as a output port. Okay, how to write? Okay, how to initialize your port C as output port in C program? So you just write down DRC sama dengan 0x FF. Okay, just like that. Okay, actually this one for this one supposed to be 1 marks lah, but since in the previous the question I took here is it needs you to answer in the what we call assembly language. So assembly language, to initialize your port as a output port, you need 2 line of instructions. So that's why it gives you 2 marks there. But basically it is 1 mark for the C programming. Okay, next. Okay, so write a C program, okay, to display digit from 0 to 9 on the 7th segment. Okay, the time interval between the digit display is about 1 second. Okay, assume that subroutine delay 1 is already developed for the program. Okay, how to do that? Macam mana nak buat ni? Okay, you're going to display 0 to 9. Okay, this code here, okay, the code already provided dekat atas ni. Okay, mana saya punya mouse? Where's my mouse? Okay, this is the code. Okay, the code already been provided here. Okay, to display 0 to 9 to the 7 segment. Okay, so by using this code here, you're going to write down a program to display this number here to your 7 segment with a time interval between the digit display about 1 second. Okay, and it already it says that the delay 1 already been provided. So macam mana nak buat? How to write the program? Okay, first thing first, what are you going to do? So you need to include what file here? Include avr/io.h. Okay, so include this file. Okay, include this header. Okay, next. You start lah with your main program, int main void. Okay, after that, what are you going to do? Okay, we have a open curly bracket and close curly bracket down here. Okay, lepas tu we need to initialize our input output port lah, betul tak? Okay, initialize our input output port. Okay, since for this one here only port C are connected to your output, so initialize your port C as our output port. DDRC sama dengan OXFF. Okay, lepas tu next, what are you going to do? Anyone? While 1. Okay, while 1 tu belum lagi. Before we start with while 1. Okay, actually for this one here we have 2 type of solution lah. Ada 2 jenis solution ya. Okay, satu we using a loop, the other way we not using a loop. Okay, let's look at the first solution here. We using a loops lah. Okay, we use 4 loops. Okay, first, you see this code here, ada code tak kat atas ni? Okay, to display the 0 to 9. Okay, to use a for loop, okay, you need to put this code here Okay, you need to put this code here into a array. Okay, you need to put this code here into an array. Okay, so similar to what we did in the last week. Okay, so you just put UINST. Okay, which is you, sorry, no S, UINT8 underscore T. Okay, so let's that code here we panggil dia sebagai SS code. Okay, 7 segment code. Okay, so you put a bracket here, so it will because this bracket here used for an array. Okay, and started, okay, this open clear bracket. Okay, started with the code that you want to put inside of this array. Okay, started with 3F followed by 06 and then 5B. Okay, you copy back the code earlier sampailah until 6F. 6F. Okay, so you put all this code here, okay, to display number 0 to 9 to this SS code punya array. Okay, next, what are you going to do? Okay, we're going to use a for loop. For Z equal to 0, okay, and then Z smaller than 10. Why is Z smaller than 10? Kenapa Z smaller than 10? Because you want to display from 0 to 9, betul tak? Okay, so you need to make sure that your Z is smaller than 10. Right, and then Z plus plus. Okay, so for this for loop here, you have how many loops? 10 loops lah, 10 kali. Okay, to display from 0 to 9, you need to do a 10 times. Okay, you need to do this for loop 10 times. Okay, for Z equal to 0, Z smaller than 10, Z plus plus. Okay, next what you're going to do? Okay, so open curly bracket for your for loop. Okay, then you set out port C. Okay, this is where you connect to your, what we call here, your 7 segment lah. Port C equal to SS code, okay, bracket Z. Okay, what happened here? Okay, when Z0, what happened is, I put here, I letak kat sini, when SS code 0, okay, the first array from this data here is 3F, so it will take the 3F value. Okay, when your SS code is 1, okay, it will take the second value, which is 06. Sampailah SS code 9, which is your Z here, equal to 9. Okay, what happened is, it will take the last code here, which is 6F. Okay, semua boleh follow all of you can follow This is how the array works. Okay, and then once you display the value, okay, to your 7 segment, what you going to do? Okay, you need to call a delay, betul tak? Okay, you need to call a delay of 1 second. Okay, so how to call a delay? Just put the delay 1. Okay, make sure that the names, okay, is similar to this subroutine here. Okay, pastikan dia punya nama sama dengan this one. Okay, lepas tu nak buat apa pula? Next, what you going to do? Just close the curly bracket. Okay, so it will do it berapa kali? 10 times. Okay, this will keep looping 10 times until Z equal 10. Okay, which is when Z equal 10, it will exit this for loop. Alright, okay, before that, because you're going to use a Z here, so that you need to declare lah this Z here. Is it an integer or char, unsigned char? Okay, so you need to declare this Z here, this variable Z as a unsigned char Z. Kenapa? Because kita takut nanti ada syntax error. Okay, if you not declare this Z here, maybe if you try to compile, you got a syntax error, which is the Z variable is not found or not declared. Okay, so that's why we need to declare the Z variable as a unsigned character. Okay, let's lah. If you're going to display the number from 0 to 9 continuously, what you're going to do? Okay, you just put your for loop inside of your while loop by using the while 1. That's all. Macam tu je. Any question for the first solution? Okay, this is the first solution. Ada soalan tak? For the first solution. Semua okey ke tak ni? Ha? Okay, semua okey. Okay, next we look at the second solution here. Okay, the second solution we're not going to use this for loop. Okay, kita just hantar, we just send out the number accordingly to this code one by one. Okay, kita hantar first we send out the ni ya saya punya ni. Okay, first we send out the 3F, call the delay, and then after that we send out the 0 seed, call the delay, send out the 5V to your port C, call the delay until you send out 6F and call the delay. Means that you send one by one to your port C. So that one you're not going to use the loop. Okay, how to write down that one? Sama jugalah. Okay, sama juga. The difference is, okay, you just directly send out the code to your port C, your 7 segment. Okay, first you need to write down, okay, you need to initialize, include your header, include avr/io.h, and then started with int main. Void, okay, open curly bracket. Okay, so inside of this curly bracket here, first thing first, you need to initialize your port C so that your port C become output. Okay, and then now you're going to send out the value. Okay, so port C sama dengan OX. Just send directly the value 3F, the codes. Okay, this is to display 0 This is to display kosong. To 77, and then call your delay. Okay, tak ada value sorry, no value inside here. Okay, next send out the second value, port C sama dengan OX06, and then call a delay. But if you use this one here, you need to rajin lah. Okay, because you need to write down, okay, to copy paste this what you call here, these two line here 10 times. Okay, 10 kali kamu kena copy paste this line here. Okay, sampailah, because I not rajin. Okay, so I just keep until port C sama dengan OX. What is the last value here to display number 9? What is the code that you need to display number 9? Boleh tolong tengok tak? Dia ada tulis kat atas tu. 6F. Okay, thank you. 6F. And then call a delay. Okay, and then close curly bracket. That's all. Okay, if you want to send out continuously, okay, which is 0 to 9, and after finish 9, then you want to go back to 0 until 9, what you're going to do? You put a while loop lah kat sini. Just put a while loop, while 1, and it will do continuously. Itu je. Okay, ada soalan tak? Okay, you can answer solution 1 or solution 2, depending on you, because in this question here doesn't ask you to use a for loop, so you free to use method solution 1 or solution 2. Dua-dua pun boleh pakai. Okay, if no question, next we go to the D. Okay, complete a schematic circuit diagram in figure 5D to connect the Atmega with 8 LED parallel push button switch dekat port A and 8 parallel common anode LED at port A. Okay, so this one dia dah bagi tahu lah. LED is common anode and your switch here dia tak bagi tahu which switch that you going to use. Is it active low or active high? Okay, let's lah this one here is active low lah. This is an active low switch. Okay, means that every time you push, it will produce input 0. Okay, it will produce 0. So, macam mana nak lukis? Okay, so just draw macam biasa. Okay, so lukis macam biasa. Okay, port A. Where is my port A? This is my port A. Okay, port A need to connect to push button. Okay, so lukis lah this one here. Okay, so this switch here will connect the active low push button. So you sambung lah all these 8. Okay, from PA0 to PA7. Okay, you draw, sambungkan dia to your push button. Okay, active low push button. Okay, next. Port B connected to your common anode LED. Okay, so this one here you need to make sure that the connection is correct. Okay, so in this case here, this is a port B. Connect to common anode. What is common anode? All the positive terminal are connected to your VCC. Okay, so that is a common anode. Okay, so you need to make sure that you know dah which one is positive terminal, which one is negative terminal of your LEDs. Okay, so this positive, negative, all of these positive here are connected to VCC. Okay, make sure you put a resistor lah. Okay, to limit the current. Okay, that flow through your LEDs. Okay, so that it will protect your LED. Okay, lukislah sampai 8 kali ya. You lukis the LEDs 8 times. Okay, next. Any question for the D? Ada soalan tak untuk D? If no question, we can move go to question E. Okay, question E. Write a C programming, okay, to read a data from the push button switches and then send the data to your LEDs. Include port configuration for the switches and LEDs in your program. Okay, macam mana nak buat tu? How to do that? Ada orang, ada somebody tak nak tolong? This is more straightforward ni. Macam mana nak buat? What is the first line that you need to write? Come on guys. The first line that you need to write. Okay, because your quiz 4 is C programming. Okay, so you need to know how to write in C programming. Okay, so first is include. Okay, every time you have a C programming, make sure you include this file here. Okay, sometimes this header here will give you marks. Okay, so make sure that you write this header here. Okay, include this avr/io.hash. Okay, next. Okay, started with int main void. Okay, open curly bracket and close curly bracket down here. Okay, so inside here, what you're going to do? Okay, at the top here, you need to what? Okay, you can use the microphone if you don't want to write down in the chat box. Okay, you can use the microphone. Okay, so you need to initialize your input output port. Okay, since this one here we have mana tadi? Port A connected to switches while port B connected to LED. So DDRB, okay, initialized as a output port, while port A DDRA initialized as a input port. Okay, DDRC. Okay, for this case here, DDRC kita tak guna. Okay, we just use the DDRB and DDRA only. Okay, after you initialize your port A as an input, what are you going to do next? Because, okay, every time you connect your port to your switches, what are you going to do? Okay, lepas you initialize as an input port, next, okay, you need to enable the pull up resistor. Okay, after that, okay, so while one, because we want to, okay, because you're going to read the switch button, okay, this push button here, and then after that you send the any value that you insert to your push button and send to your LEDs. So this one will do continuously. So that's why we use a while loop. Okay, so inside of this while loop here, what you're going to do? Okay, we need port B equal to pin A. We cannot do that. Kita tak boleh directly port B equal to pin A. We need to put the value from, read the value from pin A, masukkan to another variable, and then after that, from that variable we send out to port B. Okay, we cannot do it directly because sometimes there is an error. Okay, kadang-kadang dia ada error kat situ. So we need to put to another variable, and then after that, from that variable we send it to the port B. Okay, macam mana nak buat? Okay, so you just put another any variable lah. Okay, you want to use, okay, read data. So let's like I put a read data equal to pin A. Means that everything that you key in the push button here, okay, will go to your pin A, and from this pin A here you store at your read data. Okay, and then after that, the value from this read data here you send out to your port B. So port B equal to read data. Okay, before we stop here kat sini, what you need to do? Okay, you need to declare your read data punya variable. Is it a character or is it an integer? Is it an unsigned value or any other data types? Okay, so you need to initialize your read data punya data type. Okay, so we just put here unsigned char read data. Okay, so that's all untuk E. Okay. Okay, next. F. Okay, kita ada berapa? Okay, so this is the last question lah. Okay, modify the 7-segment display in circuit in part A to allow double decimal digit being displayed on the modified circuit. Connect using only a port C. Okay, now what happened is, previously, this is your port C. Okay, so this is your port C. So previously what happened is, this port C here, you connected to only one 7-segment display. Okay, why char read data? Okay, because, okay, you need to refer back to the, what we call the slide, okay, module 9. and 10. Okay, so this one char is char is 8-bit data. So that's why we use the 8-bit, because this one pin A is 8-bit. Okay, so that's why we use the char. Okay, so please refer back to module 9, module 9 or module 10. Okay, data type. Okay, refer to data type. Okay, I already explained the data type. Okay, now, okay, so previously port C are connected to the only 177 display, but now you need to connect 277 display, okay, to your port C. Okay, can you directly connect this one here parallelly macam ni? Boleh tak? With the same what we call here, the same pin here. Boleh tak kita buat macam ni? Okay, cannot. You cannot do that. So, how to do that? Macam mana nak buat? Okay, how to extend this port C so that this port C can allow 277 display connected to the same port. Macam mana nak buat? How to do that? Anyone? How to do that? Tak tengok lagi lah saya punya video kan? Betul tak? Do you see my video already? On the I/O? Okay, we need to use a buffer. Okay. So this is your port C. Okay, so port C, let's say lah this is a PC7, this is PC0. Okay, so you need going to use the two buffer here. This is how you want to expand your output port. Yeah, if your output port not enough. Okay, so this buffer here got enable inputs. Okay, so for this buffer here you have, betul tak buffer ke latch? Saya pun dah lupa dah. Mana satu yang betul? Okay, sekejap ya. I check back my slides here. Okay, then I share it to you. Maybe REC buffer. Sekejap. Okay, we are going to use a latch, yeah, not buffer. Buffer to increase the input, while latch to increase the output. Okay, you can refer to this slide here. Macam mana nak share? Alright, share. Okay, can you see my slide here kat sini? Okay, it's inside of your module 10. Okay, this is how you want to increase the number of input. Okay, by using a buffer. Okay, if you're going to use a buffer to increase the number of input at the same port, okay, you need to use a buffer. If you're going to use the to increase the number of output to your ports, okay, you're going to need to use a latch. Okay, so in this case here we are going to use a latch, right? So you see this latch here, kamu tengok sini, dia ada satu enable here. Okay, to enable which latch that you're going to use. Is it a latch kosong ataupun latch 1? So same lah, sama juga dengan this case here. Alright, so this latch, this is latch 0, this is latch 1. So this latch here we connected to our 7 segment lah. sambung pada 7 segment, which is a common catet punya 7 segment. Okay, so this is 8-bit punya. Okay, all the what we call here, the pin is connected here. Okay, kena properly connected lah. Okay, so this P7, okay, go to here, and then you have P6 until lah PC0. Okay, so you have a 8-bit. Sama juga dengan yang ni. This one here go to here, P7. This one will go to PC6, and this one will go to PC. Okay, so you have a 8-bit punya connection kat situ. Alright. So next, now this one, this guy here, the enable. Okay, so this enable here, you can connect this enable, okay, to any other of your port. Contohlah kat sini, I sambung pada untuk question 1, kita tak pakai yang mana lagi ya? For question 1, which port that we are not use? Okay, we have port A, port B, and port C. Tak guna. Port A, port B, and port D. Okay, let's say lah this one here, I connect to PA0, while this one here I connected to PA1. Okay, so this is how you're going to modify this circuit here. Okay, for more explanation about the buffer, this slash here, okay, how to expand your input and output, you can refer to my video. Okay, module 9 sorry, this is module 10, because module 9 is basic introduction of C programming. Module 10 is a IO programming. Okay, I think we stop here. Okay, next week we continue with question 6 and question 7. Any other question tak? Ada soalan tak? Ada soalan? Any other question? If no question, maybe we can stop here and see you next week. Okay, attendance. Okay, attendance. For those who not sign the attendance, please sign sekarang. Test. We don't have test. We have 4 quiz. From that 4 quiz, I will take 3. Best 3. Okay, to make it as your carry marks. Okay, so quiz 4, I already give to you in the what we call here WhatsApp. Bila ya? Berapa hari bulan? I told you 24 June. Quiz 4 24 June. Yes, quiz 30% of the total marks. Okay, 20% is coming from your assignment, individual assignment and group assignment.